Hi everyone, here is our math problem for today. We are given here a circle with two blue shaded regions. We would like to find what is the combined area of these blue shaded regions. Let's begin by analyzing its basic components. We start with a circle with center at point O and these two intersecting chords. They intersect at 90 degrees. Then we connect their endpoints this way and shade these blue shaded regions and these given measurements. So what is the combined area of these two blue shaded regions? You can pause the video and see if you can solve this geometry problem. Now let's solve this problem together. Let's begin by connecting this point here, passing through the center to the other side of the circle. In other words, we constructed a diameter, and let's label this diameter as diameter AB. Then from point B, let's connect that point to this point of intersection here to form segment BC. Then let's label the other parts. Let's call this point D and this point as point E. Now, what can we say about AB? Segment AB is a diameter. That means this line segment divides the circle into two semicircles. So BEA is a semicircle that subtends angle BCA. And recalling our inscribed angle theorem, the measure of the inscribed angle subtended by the arc is half the measure of this arc. In other words, the measure of this angle here is 1/2 whatever is the measure of this arc that subtends this angle here. And knowing that this is a semicircle, then it follows that the measure of angle BCA must be 90 degrees because this angle is 1/2 180 degrees, which is the measure of a semicircle. Let's call this angle here as angle alpha, and let's call this angle here as angle beta. If the angle here is 90 degrees, and since the sum of the interior angles of a triangle is 180 degrees, then the sum of alpha plus beta must be 90 degrees. In other words, alpha and beta are complementary angles. Next, let's connect point D to point A, and let's look at this triangle. Notice that angle ABC is an inscribed angle subtended by arc AC. This means that the measure of alpha is 1/2 the measure of arc AC. Now let's look at this triangle here also, triangle CDA. Notice that this inscribed angle here is also subtended by the same arc AC. So since these two angles are subtended by the same arc AC, and if the measurement of the first angle is alpha, this angle here must also be alpha. They have the same measurement because they are subtended by the same arc AC. Notice now that we have here alpha and we have here a right angle. That means whatever is the angle here plus alpha, they must be complementary angles because the sum of the interior angles of a triangle is 180 degrees, and we already have here a 90-degree angle. And we said that alpha and beta are complementary angles, so the angle here must be beta. So let's label it as beta. You have here beta, and that interior angle intercepted this arc ED. You have also here beta, and the same interior angle also intercepted this arc BC. That means this blue shaded region here must be identical with the region here, and so we can move this blue shaded region here so that we can just focus on this part here, which is located in one side of this semicircle below. If it was 4 units here, then this must also be 4 units because these two regions are identical. Now at this point, we are now ready to find the measurement of the diameter because you have here a right triangle ABC. From the Pythagorean formula, the length of our diameter AB is equal to the square root of the sum of the squares of the two shorter sides. So we have here 4 squared plus 8 squared. So solving for the length of segment AB, 4 squared is 16, 8 squared is 64, and 16 plus 64 is 80. So the length of segment AB is square root of 80, or 80 is 16 times 5. The square root of 16 is 4, and copy square root of 5. So the length of our diameter is 4 square root of 5, which means that the radius is 1/2 4 square root of 5, so the radius is 2 square root of 5. Now that we already know what's the length of the radius, then we can now find the area of the semicircle. The area of the semicircle is 1/2 the area of a circle, so it's 1/2 pi r squared. We know that r is 2 square root of 5, so substitute that in the formula. We now have here the area of the semicircle, s, is equal to 1/2 times pi times the square of 2 square root of 5, which is 20, and that simplifies to 10 pi square units. Let's remember that result. Now let's find the area of triangle ABC. So its base is 4, its height is 8, area is 1/2 base times height. Therefore, the area of triangle ABC is 16 square units. Let's remember this result also. So, we know the area of this semicircle and we know the area of this triangle here. So, if we are going to subtract these two values, then what is left would be the area of this blue shaded region, which is exactly what we want to find. So 10 pi minus 16 square units is now the area of the blue shaded region, and this problem is now solved. So this is indeed a very beautiful and elegant geometry question. Thank you very much, and we hope to see you again in our next video. Bye for now.